just little value adds.
Yay. And hello, beautiful humans. Thank you for joining another episode of Teach Jenn Tech. I am excited and nervous about today's episode because I feel like this is something that we all are supposed to know, yet is hard to conceptualize. So, yay, Trevor, for joining us today. Please introduce yourself and what you'll be teaching us today.
Well, hello, Jen. Thanks for having me on your show. Great job on it, by the way. It looks very professional. I like what you're doing, learning lots of new technology. Very awesome thing to be doing. But my name is Trevor Sullivan. I've been in the software industry for about 18 and a half years at this point, and held a variety of different roles, done consulting, done internal IT. But for the last couple of years, about 2.5 years now, I've been working for a company called CBT Nuggets. We create software training. We also create IT infrastructure training. I myself have taught on a range of topics from AWS to PowerShell to Kubernetes certification training to MySQL database training, GitHub Actions automation training, and a whole bunch of fun stuff like that. So I'm really passionate about just helping people leverage technology, learning new technologies myself. That's part of the fun of it. And yeah, that's kind of what I do.
Curiosity, what was the first piece of tech that you learned?
Ooh, that's a good question. Well, I mean, back in my earliest IT days, back in like early 2004, I remember one of the earliest things that I was working with was this program called Norton Ghost. And any old timers are going to laugh at me for using that software, mentioning that name, but Norton Ghost was the imaging product that we used to make replicas of hard drives to replicate desktop computers. So we'd basically make kind of a master image and then, copy that to other computers. And that's how we would roll out desktop and laptop systems.
Interesting. I never knew that existed.
It's funny
In
to even
general.
talk about it.
What up, Anthony? Okay, interesting. And I know today we're going more of the when do you use Kubernetes and when do you use Docker, and then the cool things PowerShell can do with Kubernetes. But when did you start working with these products?
Let's see, Kubernetes is relatively new to me. I mean, it's been around since I want to say 2014 or 2015, at least in its very early stages, when it was still initially a Google project. But I've only been using Kubernetes for probably less than a year at this point. So it's still pretty new to me. But PowerShell,
Nice.
I've actually been writing almost since it came out, probably like 3 to 6 months after it came out in 2006. I've been writing PowerShell.
Okay. And hi, Helmi. And Anthony was one of the first people on the show and has been a part of this journey. And he said he has a hunch that I'm not going to need to be using Kubernetes anytime soon. Docker, though, is something I'm going to use consistently. Well, you lead me to my next great question. I feel like it's a great question. What are they? Because I've installed Docker once and I didn't know what I was doing with it. And I know that I used to have a ton of Docker shirts because a family member used to work there at one point. But this was before I knew what it was. And I'm kind of sad because I gave all those shirts away and I'm like, it's so cool now. But that is, I don't know what they are. I know what they are, but I don't know what they are.
You
So
gave them away?
well, it was in all the shirts, I gave them away in 2017 probably, because I didn't know what Docker was. It was just a cool whale thing. That's all I knew of what Docker was.
With a bunch of containers on its back, what does that have to do with technology? It's all about logistics.
That's kind of what I thought. And so containers, before we go through Docker and Kubernetes, what's a container?
So I'm probably going to do a terrible job explaining this, but the way that I would describe a container is it basically it's a level of isolation. So I like to kind of equate it to a virtual machine, but it's not a separate virtual machine where you have a virtualized CPU and virtualized memory, virtualized disk, virtualized networking. but it does have its own level of isolation. It's just isolating at the process layer. So on your Mac OS system, which I believe you're on a MacBook, Jen,
Yeah,
you run Google Chrome, you run Firefox, you run iTerm2, you run different applications on your computer. Well, each of those is a separate process, or in some cases, multiple processes. If you look at Activity Monitor on your Mac, you'll actually see a bunch of different Chrome processes in there, probably for each tab that you have open. And so Docker kind of allows you to isolate programs at the process level rather than at the hardware level like virtual machines do. And so containers use a few different underlying Linux kernel technologies, like what's known as namespaces, Linux namespaces, as well as C groups to control access to the underlying hardware resources. So what that does is it allows you to kind of isolate a process and say, you're only allowed to use X amount of system resources. And if you try to exceed that, then we're going to basically kill you off, and you can restart if you want to, but you're not going to be able to exceed this particular limit. And so that can prevent contention for system resources and kind of do fair sharing of resources across a single system, or in the case of Kubernetes, across an entire cluster of resources. So a container is kind of a way to kind of isolate a process and kind of box it into its own little segment of the system and prevent it from kind of stepping on the toes of other processes. And that actually works at the file system level too, which is really powerful, because what it lets you do is, if you've ever tried to do, you mentioned TypeScript programming, or if you've ever tried to install like Python or any other runtimes, then you can actually run into a lot of issues when you try to install multiple versions of runtime. So if you try to install like Python 3.9 and Python 3.10 and Python 3.6 and Python 2.7 all at the same time, then these different versions of different Python runtimes can actually step on each other's toes. But when you use something like Docker, or containers, I should say, to isolate the file system, then these different versions of a Python runtime or a PowerShell runtime or a Ruby runtime, they can't step on each other's toes. And so you don't have that, in the Windows world, we always called it DLL hell, where you have different versions of libraries that are kind of mismatched with each other, and this version of Python depends on this version, and this version of Python depends on this different version, and so it really avoids that dependency hell. It just kind of,
yeah. I
yeah.
just went through that on Monday.
Oh,
It was fun.
with which runtime?
I'm thinking about it. Thinking
Was
about it.
was it
Was it?
TypeScript or
No, it actually, I think it was the Anthony, which one was it?
Node?
We were doing a lot. I think it might have even been for Node. I think it was Node, so I could do the GitHub CLI.
Gotcha.
And yeah, so Node 18 is the newest, but what I was trying to clone and use was on like 18 or 16 dot blah blah blah, so it didn't let me do it. And then I tried just installing the lower version, and it wouldn't let me do it because it had 18 on there, and I was going to get my Mac back soon, and it's having its own issues. So if I do randomly disappear while you were talking, my Mac just shut down all of my screens and then turned them back on. So I'm hoping for the best on this stream.
I can still see you.
Yes. Okay. Um And then Anthony just said GitHub CLI is done through Homebrew, probably. Oh, it was Node for open source, not for GitHub CLI. Okay, cool. See, this is
Node for
why
open what?
open source, it's a open sourced repo that B. Dougie started. It's actually really cool. I will put it here in the chat here shortly. Give me just a second. It's pretty cool because it's one of the first ones, like, as I'm learning to use GitHub more, like you've talked about GitHub Actions, and I'm really excited to hear about that later on. But I've learned a little bit about it, but we were talking with Open Source on Monday because of Hacktoberfest and contributing to open source. So, um, now If I was hearing you correctly with the explanation of a container, I like how you mentioned it's different than a virtual machine, and then if I heard right, the container has a specific size limit.
Yeah, you can limit resources like CPU and memory so that it can't chew up all the CPUs on your system and break everything else, basically. Yeah. And
Okay.
that's a feature in the Linux kernel called C groups, I believe. Or is it ulimits? I can't remember. I think it's C groups. Yeah, C groups allow you to allocate resources such as CPU time, system memory, network bandwidth, or combinations of these resources. So yeah, that's like a Linux kernel feature that's been implemented by container runtimes like Docker or ContainerD. And
Are there more than just Docker and Kubernetes? Those are like the only ones I've really heard of.
yeah, there are actually other tools out there. So there's ContainerD. ContainerD is a runtime, and Kubernetes actually shifted from using Docker under the covers to actually create and destroy containers to using ContainerD relatively recently. They made that switch, I believe, in 1. Can't remember if it was 1.24. But yeah, they switched over to using ContainerD instead of Docker now. I guess probably due to licensing reasons or something like that. But then there's also Podman. Podman is another container tool that you can install. There's a CLI tool that you can install to spin up containers on your local machine. But I don't think Podman really has any clustering capabilities like what Kubernetes or Docker Swarm do.
Gotcha. I'm also Googling over here and I just saw Anthony's comment. These used to be a full-on industry-wide war over Kubernetes versus alternatives, and Kubernetes ritually slaughtered all the competition. Oh, damn. Okay.
Very true. In
Um,
fact, I remember attending DockerCon, um, where I met your family member back in, I think, 2016. And there was a pretty big war going on between like Apache Mesosphere, I think was another project. And then there were some other orchestrators out there. I can't even remember what they were called, but yeah, that does ring a bell. There was a little competition.
Interesting.
You
Okay,
don't really hear
so
about them anymore.
yeah, and containers like Docker is what I just Googled, and it is coming up with quite a few other ones, as well as like, is Kubernetes the same as Docker? And it definitely supported what you were just saying, like Kubernetes or Docker is like a single container, and Kubernetes is a system for operating containerized applications at scale. That the words make sense. And I take that as like Docker is like I was actually showing my friend is not technical whatsoever, so I'm trying to like show her what I'm talking about today, and this was my explanation. I'm going to use it with pens. Pens, they're fun. So this is like Docker, and you can have like separate containers at Docker, but none of them are going to go together. Where Kubernetes is like they're all together. And if I remember right, if one fails, one of the other containers will help it. Is that accurate?
You can load balance network traffic across containers for sure in Kubernetes. That's actually a big value of Kubernetes is its load balancing capabilities. So yeah, if one pod fails, then another application pod can kind of take over and serve requests for that application. We generally refer to that as high availability. So rather than just having a single instance of an application that could fail and cause an outage for all of the users of that application, we could have 10 instances of that application. And then when a user tries to hit that application, they get routed to one of those 10 instances of the application. And we refer to that as kind of load balancing traffic across multiple instances of the app. So that could be a database server that you're doing load balancing across. You could have a client application that's hitting different instances of a database server. If you have replicas of a database, you could also have it be a web application. So if you have a web application, maybe you have 3 or 4 containers running that same exact code. And then when a user tries to go to teachgentech.com, they hit maybe container number 1, and then another user comes in and they hit container number 4, and then another user comes in, they hit container number 2. So yeah, load balancing and high availability is a big value of using Kubernetes for sure.
And okay, that's starting to make a lot of sense. And I liked what Anthony added in. Like, uh, Kubernetes is like a bunch of Docker containers speaking to each other. And so I guess that really does lead to like the next question of what would you use a Docker container for, and what would you use Kubernetes for? Like, I think that's the other piece, like learning what they do, but having like a real life example of what they do.
So in the real world, Docker, generally speaking, I would say is used more as a local development tool. So if you want to install Docker on your MacBook, or if I want to install Docker on my Windows machine, or maybe install it on a Linux host somewhere, I can use the Docker CLI to kind of manage containers on each of those systems individually. Now, Docker does have a clustering mode where I can create a cluster of Linux virtual machines and join them all together into what's known as a swarm cluster, which has a little bit of overlap with Kubernetes, but when it comes to clustering capabilities, Kubernetes is much more powerful, I would say, than Docker Swarm. If your needs are very basic for clustering, then a Docker Swarm cluster might be enough, but Kubernetes is really where the industry is headed for kind of large scale container management. So the reason that you would use Kubernetes is if you're deploying, production grade applications that you need to deploy in the cloud and have shared access to. So Kubernetes has shared a permissions model called role-based access control that allows multiple users to have permission to manage different resources. Kubernetes also has this logical concept called a namespace. It's not the same as a kernel namespace, so there's some ambiguity that you kind of have to get familiar with. So there's Linux kernel namespaces, which is a feature that containers use, but then Kubernetes itself has this concept called a namespace, which is also a term used in software development, but it basically just allows you to kind of carve out a piece of the cluster and say, okay, you, Jen, have access to this namespace. Trevor, you have access to this namespace over here. And any resources that I create in Kubernetes in each of those namespaces is going to be permissioned based on who has access to each of those namespaces. So that's a capability that exists in Kubernetes, but does not exist in Docker Swarm. So that kind of is why I'm suggesting that Kubernetes is more used for production grade deployments, whereas Docker is used, generally speaking, more for kind of localized one-off containerizations.
Anthony said he doesn't know if he should run Docker containers in prod all the time now because so many services have been made really easy.
I mean, you certainly can use Docker in production. There's nothing preventing you from doing that. It just kind of goes back to things like the load balancing capabilities of Kubernetes that make it a lot more powerful, a lot more, I guess, robust, I would say. But I mean, there's nothing preventing you from spinning up a Docker Swarm cluster and running multiple containers, doing load balancing on Docker Swarm. I know it supports that. But again, Kubernetes is just a much more flexible solution. So if you need to add on kind of bolt-on capabilities in Kubernetes, which you pretty much have to make it really useful, it's just going to give you a lot more capabilities than what Docker Swarm would.
Okay, and I know like my first intro to Kubernetes was really through Denver Startup Week, and there was a company that came to present, and they basically uh, will help a business launch their cluster with all the applications that they need for it. And I think just like where my head goes with that is, would you ever put those same type of applications in a Docker container? And then also, like, how do you choose between all of the options in Kubernetes?
So if I understand your question correctly, you're asking how do I determine if I should or shouldn't run an application in a container?
Yes, that's a good
Okay.
way of saying it.
Just wanted to make sure I understood that properly. So containers are generally used for server-side applications. This is things like web servers, database servers, background processing tasks. So if you think about a platform like YouTube, for example, right? If you go to YouTube and you record a video, you upload that video to YouTube, and then YouTube does some backend processing on your video before they actually publish it, right? That so it shows you right in the YouTube studio there that it's running some processing tasks, and it takes a while for that to happen depending on how long your video is or things like that. But those kind of background processing tasks could be theoretically run in containers. Obviously, I don't know how YouTube has implemented that functionality, but I'd be very surprised if they were not using containers on the back end to process those videos with some utility like FFmpeg, for example, which is a Swiss Army knife utility to process videos into different formats. But my point is that generally speaking, containers are used for kind of server-side applications that are running on the back end. Now, there are some advanced ways that you can actually run graphical applications like Firefox or Chrome or draw.io, which I just we were talking about prior to launching the live stream. You can technically run a graphical application inside of a container, and then you can connect an X server to that application that's running in the container. So you can achieve the benefits of isolation of applications that are graphical in containers, but that's a little bit more of an advanced use case, and it's not, generally speaking, what people are doing with container-based applications. So generally speaking, you wouldn't really want to run Firefox in a container because if you download a file with Firefox and you download it inside of the container, well, now that file exists inside of the container's file system, and you on your Mac desktop need to have access to whatever that file is that you downloaded.
Mm-hmm.
So you'd have to go into the container to get the file, and that just kind of complicates things. But it is possible technically to do those kinds of things.
All right. So I think I'm starting to see it all, but where do we get started in getting Kubernetes or Docker? And we got a question from Rivet. Why is it better, or is it better to run backend on a Docker container Kubernetes cluster instead of, say, of a EC2 instance?
So an EC2 instance is basically just AWS's terminology for a virtual machine. So you can spin up a Linux virtual machine anywhere. You can use AWS, you can use Azure, you can use Google Cloud, you can use Linode, you can use DigitalOcean. You can even spin up virtual machines running Linux locally on your dev desktop using things like VMware Workstation or VirtualBox or other hypervisors like that. So basically, I think what the question is kind of boiling down to, though, is like, why would I want to run a container-based application on, let's say, a managed Kubernetes service rather than like self-managing a virtual machine? So you as a developer can go out to a cloud platform like AWS, you can spin up a Linux virtual machine, you can install Kubernetes on that virtual machine, and that's what we would consider to be a self-managed cluster. But you can also go out to these cloud providers, and all the cloud providers that I just mentioned all provide managed Kubernetes distributions. So you can basically go out to the cloud provider, and instead of saying create a Linux virtual machine, you can say create a Kubernetes cluster. And so rather than using SSH to go into that Linux virtual machine and installing Kubernetes yourself, you're basically just spinning up a pre-built Kubernetes cluster from that cloud provider, and then you're able to use kubectl, which is kind of your client utility to manage Kubernetes, to talk directly to this managed cluster rather than having to self-install and self-manage that cluster. So I think that's kind of where that question was going towards. And it's kind of a loaded question because there's not a right answer for anybody. Some people might be able to get away with using a managed Kubernetes distribution. However, when you use a managed Kubernetes distribution from a cloud provider, it does prevent you from configuring certain backend components of Kubernetes, like the API server, the controller manager, and the scheduler. Those are kind of the three critical components of the Kubernetes master nodes. And when you use one of these managed cloud distributions of Kubernetes, they prevent you from configuring those components. They manage all that stuff for you. So if you have an advanced use case where you do need to configure some of those backend Kubernetes master node components, then a cloud managed distribution of Kubernetes would not be right for you. Instead, you'd want to look to a self-managed distribution of Kubernetes.
Rivet, did that help? And in the meantime, Homie said before he understood that to think Docker containers as a mini PC that only does one thing in one process, Kubernetes is a computer that joins controls as a bunch of mini PCs, very general.
Yeah,
All
I mean,
right.
any way you want to think about it that makes it easier for you is totally fine. But yeah, I mean that's not a bad way to think about it.
I was like, I was going with pens. Earlier, it was when I was explaining it to my friend, it was spices. So um, maybe a better wording is why a container versus a VM.
So
Great
that is a
question.
very good question. So as far as containers versus virtual machines go, containers do not spin up a virtual machine. There is no separate kernel. Like there's no operating system kernel that gets spun up for each container that gets created. Rather, when you create a container using Docker or ContainerD or Podman or whatever, then what happens is that these namespaces get created inside of the Linux kernel, and each process can only see certain parts of the system based on what's exposed to it through these kernel namespaces. So rather than having like in a full virtual machine environment, like if I create an EC2 instance on AWS or if I create a Linux virtual machine on DigitalOcean, that's giving me an entire virtual machine with its own separate Linux kernel. And I can install different versions of the kernel. I can load modules into the kernel if I want to, because I control that kernel. But if I create a container, I don't have my own separate kernel that I can manage. It's actually a process level of isolation that's happening. So in terms of why you would want one versus the other, it kind of boils back to why would you want a single physical server that I can create multiple virtual machines on, right? Because you get better density, you get better, more efficient utilization of that single physical server by creating 10 or 20 or 30 virtual machines on that single physical server, right? Because if I take a single physical server and I install an operating system on it, and then I run just one application on that physical server, I'm probably wasting 95 to 99% of that server's capacity, because unless you're running some really heavy application, you're probably not going to be utilizing all the CPUs and all the memory and all the disk of that server. So the way that we achieve better efficiency is by running additional virtual machines on the same physical server. Well, apply that same concept of density and efficiency to the process level. If I spin up a Linux virtual machine, but I only install one application on it, then I'm probably wasting 99% of the resources of that single Linux virtual machine. So what I can do is I can spin up more applications on the same server, on the same Linux instance, and I'm getting better efficient utilization of the resources on that system rather than just wasting 99% of its capabilities.
In theory, is starting to make sense, but I feel like this is all of tech of like it makes sense, but then it's also very, very confusing at the same time. And I don't know, I didn't know that this happens before, starting Teach Jenn Tech a few months ago. So um, I think just like piggybacking off of what Rivet said and glad that it helped Rivet. Yay. Would be something of how words, Jen. How do we go about like I've seen a bit about like installing virtual machines and that kind of thing. Now, yet using Docker Kubernetes is very different. And you and I talked about pre-show a bit about doing and if I'm paraphrasing this properly, is like doing a local install of Kubernetes or using a cloud Kubernetes. Um, First question, is Docker the same where you can do a local versus a cloud? And for both, when would we use them and can we go through those examples?
You mean, yeah, certainly we can go through those examples. Generally speaking, Docker does not, most cloud providers don't provide like a managed Docker Swarm cluster type of thing, like they do with Kubernetes. The cloud industry has kind of standardized on Kubernetes as a container orchestrator. So that's why if you go to AWS or Google Cloud, you're not going to see an option in their cloud platform, in their portfolio of services, to like create a Docker Swarm cluster. Now you can create your own Linux virtual machines, and then you can install Docker on all of them and run the commands to create a Swarm cluster and then join all those machines to a Swarm cluster. But those cloud providers are not going to provide that same kind of managed service for a Docker Swarm cluster like they do with Kubernetes. But you can install Docker on a virtual machine. You can install Kubernetes on a virtual machine. If you control the virtual machine itself, or multiple virtual machines, then you can create your own clusters, configure your own clusters however you want to. Now, one of the things that we had talked about a couple of days ago, or I guess last week, maybe when we initially got in touch, was that there's a bunch of different Kubernetes distributions out there. So if you do want to run Kubernetes yourself on your own Linux virtual machine, like on your laptop or on my Windows 11 developer workstation here, if I want to install Kubernetes on my own local Linux virtual machines, there's a lot of different Kubernetes distributions and tools that you can use to actually instantiate a Kubernetes cluster. My personal favorite that I actually use in a lot of my training for CBT Nuggets on Kubernetes is called K3S. So if you go to k3s.io, it's a very well-supported distribution of Kubernetes from Rancher Labs that allows you to rapidly spin up a cluster. It's just a single binary, so you literally just download K3S itself, and then it contains all the different components of Kubernetes. And it also gives you a lot of control over passing in different configuration options to each of those components that I discussed previously, the Kubernetes scheduler, the API server, and the controller manager. And so you can customize, like the logging paths, like where to spit out log files. You can enable audit logging on the API server if you want to, which is a little bit more of an advanced security feature. And it gives you just that full control, but it also gives you that simplicity because it is just so easy to spin up a cluster. But if you want to, you could also use more official utilities. Like the official utility to create a cluster is pretty complicated, so I wouldn't recommend it to newbies, but it's called
Okay.
kubeadm, short for, I think, kube administrator or something like that. But it's basically the command line tool that you use officially from the Kubernetes project to create and configure a cluster of Kubernetes nodes. Much harder to use, but it also does give you a lot more flexibility, and it is also the official tool from the Kubernetes team. So that's kind of like the best way to go if you're looking for the most raw experience.
I'm letting that soak in because so it's the k3s.io, I believe.
Mm-hmm.
I'm taking a look there just to see if they also have a very, very bright website. I think my screen will let me make friends. We'll find out. Give me just a second and we'll see if my computer. Okay, cool. So I'm taking a look at it and a I feel like Ben, he's not here, but he makes me think about accessibility and doing the contrast, and I'm like, I can barely read the white on the yellow, and it's so funny. He's like always in the back of my head. So okay, cool. You run this, and you got it.
It's literally that easy.
Cool. So we got that going for us. I'm not going to do it just yet, but this is like one place we could start. Or you said that we could start with DigitalOcean, right?
Mm-hmm. So
So,
DigitalOcean is a kind of, I always like to think in the cloud world, there's like the big three cloud vendors: Microsoft Azure, Amazon Web Services, and Google Cloud Platform, GCP. But then there's a lot of smaller cloud vendors out there. DigitalOcean is one of those. They're actually a publicly traded corporation, so they are pretty large. But then there's also some others like Linode. I use Linode pretty heavily. And these smaller cloud providers have a lot of benefits. Number one is they're easy to use because they don't have the massive portfolio of services that some of the major cloud vendors have. So it's a lot more straightforward of a platform to use for people who are new to cloud. And also their pricing, one of the things I love about them is that their pricing is a lot more straightforward. If you get deep into the pricing of the major cloud vendors, especially like Amazon Web Services, their pricing is so complicated to figure out that it can really cause your head to kind of spin. So what I like about DigitalOcean, or Linode for that matter, or Vultr, is that they have simple platforms. It's like, here's your virtual machine infrastructure, here's your Kubernetes clusters, here's your managed databases, but that's it. And their pricing is very straightforward. It's very competitive pricing as well. So they're not trying to screw you over. It's actually a very pleasant experience.
Yeah, and I totally didn't set this up beforehand to do the account. So, do you
That's
have
okay.
one on DigitalOcean that we could check out?
Yeah, I spun up one actually on the Linode platform. So if you want to share my screen, you're more than welcome to.
Sweet.
So I've created a Linux virtual machine here. It just has 2 CPU cores and 4 gigabytes of memory and a little bit of storage here. It's plenty for doing a basic cluster here. It just gives you a public IP address here, and then you associate an SSH key just to authenticate to the cluster. So I can connect to this cluster from any machine. I could do it from Jen's machine if I wanted to. I could do it from my Windows machine here, or I could, if I was running Linux locally, obviously every operating system these days has SSH built into it. So if I just run SSH root at IP address, I should get automatically logged in here once I confirm the host key. And boom, now I have my own Linux virtual machine running up in the cloud. And if I wanted to, I could destroy that Linux virtual machine, create a brand new one, start from scratch again, and I'm good to go. Now, the Linux distribution that I have installed on this machine, so when I created this Linode machine here, I chose the Ubuntu Linux distribution, which is extremely popular. It's from Canonical. They make awesome software. Ubuntu's been around for a very long time. I typically use the LTS, the long-term support version of it, just because it's more stable than the interim releases that they have. So like these 21.10, 21.04, those are kind of interim releases of Ubuntu Linux. So I tend to stick with the long-term support versions of it just for that stability. But there are, as you probably know, tons of Linux distributions out there. Debian Linux is actually what Ubuntu is based on. So if you want a more core Debian experience, you can just use that. You can use Fedora Linux if you want to, and a bunch of other ones out there. But I typically just stick with Ubuntu. And so I've got Ubuntu Linux running on this machine here. If I run this uname-a command, or actually, let me do lsb release --all, you can see I am running Ubuntu 22.04 here. So this command here is what I can use to kind of verify which distribution of Ubuntu I'm running here. So at this point, I've got a Linux virtual machine, and I can do whatever I want with it. I could install Docker on it. I could install Kubernetes. I could use Podman, like we talked about, ContainerD. It's really up to you what you want to do with this machine.
What are some examples of what someone might put on the machine? Is there something we can look up or put on there that is a project that someone may be working on, or an application someone may be working on, to see how that's installed?
Oh my gosh, there are tons of applications out there that you could spin up. Trying to think
Okay.
of some. For example, like Neo4j. Have you heard of Neo4j, Jen?
No.
So Neo4j is freaking awesome. Actually, it's this concept known as a graph database engine, where you have these nodes that represent things, and then relationships, which are just lines that represent a relationship between two different things. So graph databases are really cool, just because they're so simple to understand for humans. Just because our world is kind of based on graphs. It's like you have on a map, you have different addresses. Those are places, right? We have businesses. Those are things. Those are nodes. And then we have relationships, like Jen visited Starbucks, or Trevor visited his house, or whatever. And so graph databases are a really nice way to think about data in the real world. Neo4j is a company that creates their product, which is Neo4j. And Neo4j is a graph database engine that you can deploy very easily inside of containers. And one of the nice things about Neo4j is that it has a web interface that you can log into to actually create data in your own graph database and query data from your graph database once you've inserted it. So one of the things I like to kind of play around with sometimes is Neo4j. And so if we wanted to install Neo4j, one of the easiest ways to do that would be to install the Docker runtime on our Linux VM and then just spin up a container using Docker that runs this Neo4j application. So if we head out to, do you want to do that now?
Sure.
Okay. So if we head out to the Docker Hub, this is kind of a container registry that allows us to find different applications. And so if you search for, Neo4j or search for MySQL, which is a relational database engine, or if I search for AppWrite, which is this like low code runtime, that's really interesting. I mean, there's just so many different applications out here that are just pre-packaged as container images. But anyways, we've got this official Neo4j image here, and we can very easily spin up an instance of Neo4j by using this command right down here. But of course, we need to have Docker installed first on this VM. So because I'm on Ubuntu Linux here, Ubuntu Linux has a package manager that you use to install different software packages called apt. So I can just run apt and then update here. And this will just grab some metadata about all the different packages that are available. I'm not actually installing anything here, but it's just going to grab some metadata for the apt package manager. And then I can run apt install docker.io, and docker.io is the name of the package to install the Docker engine just locally on this Linux VM here. And once I've got the Docker package installed, I can immediately start spinning up containers. Or if you wanted to go down the route of spinning up a Docker Swarm cluster, I could actually create additional Linux VMs and then kind of combine them all into a single Docker Swarm cluster. But as we kind of talked about before, using Docker locally is one of the more common use cases of it. I guess I'll kind of pause there and see if you want to interject, Jen.
No, I think it's at the point where like there is a lot of it is going over my head, but I'm still like absorbing it in the fact of piecing it all together with context, but also learning where I may dig in later on and ask questions. So I say at the moment continue because I'm following along. It's just like if somebody were to ask me about it, I'd be like, oh, but it's sticking enough conceptually.
Once you do it a few times yourself, you're gonna keep going. You're gonna create a few containers, and you're gonna be like, oh my gosh, I want to spin up this application or that application. And I've actually been documenting a bunch of. Are you familiar with the awesome repositories out there on GitHub, like awesome machine learning or awesome databases or anything like that?
No, but I feel like I definitely should.
I mean, there's a bunch of different repos out there. If you just search for like awesome GitHub, I don't know, databases, like people create these lists basically of like awesome database engines, right? And sometimes they're not always up to date. Like this one's kind of outdated by a couple of years here, but there's, just these huge lists of different awesome topics. Anyways, I wanted to have control over my own list so that I didn't have to like wait for somebody to merge my suggestions. So I created this awesome Trevor repository here. And I've listed out just a ton of different software packages. Some of them are like libraries that you can load into programming languages, like down here towards the bottom, like PowerShell modules or .NET modules or JavaScript modules for different purposes. But then I've also got like a bunch of applications that you can install, oftentimes using Docker here, like database engines, for example, like Neo4j is right there, or RethinkDB, or InfluxDB, which is another one of my favorites. I don't know why I didn't think of that earlier because I love InfluxDB. It's a time series database engine for like metrics storage. Where was I going with this?
I'm not 100%, but I just saw Ramon's question of, wait, what's a swarm cluster? And I think a swarm cluster is where Docker can link multiple containers together.
Mm-hmm.
Kind of like Kubernetes, but it does it with Docker and they call it a swarm cluster.
Yep.
Yes.
You spin up a bunch of Linux VMs and you mash them all together inside of a single cluster. And then when you create a container, that container could get created on any one of those nodes in the cluster. And it's actually like really, really easy to set up. It only takes like a minute.
Okay.
Anyways, so these are a bunch of different applications that you can like learn about for different purposes.
Okay.
But Neo4j is in there. Anyways, I think I was getting off on kind of a tangent there. I don't know why I mentioned that, but
The awesome Trevor project.
yeah, it's just where I document a bunch of cool software, like mostly open source that I come across.
Okay.
But if you're looking for like container tools, I don't know why I haven't put Podman is not in here yet. But if you're looking for like Kubernetes stuff, I have a bunch of like Kubernetes things down here for different purposes. So yeah, just kind of my like personal documentation repository.
And I believe, Ramon, I think you said that you do some of this kind of stuff at work. Is there any questions that you have that you'd be curious about other than the cluster one or the swarm cluster? And yes, bye, Anthony. Have a wonderful day. Because I know we've covered quite a bit today. And I have so many things that I'm going to end up asking about later on after I let it noodle for a bit. What are some resources you would suggest for newbies to use? Would you just say like going to Linode and using their docs, or is there something else that, like, you have the training that you do with certifications as well, right?
Mm-hmm. Yeah, I build a lot of certification and kind of what I consider like practical training. Like, here's what you need to know to get certified, but then like what are the things? Certifications don't always cover all scenarios, right? They kind of focus on very specific topics. So in the case of like AWS training, they're only going to test you on like AWS stuff, right? They're not going to necessarily test you on kind of all this other software that you need to know about as a developer. And so a lot of the training that I build, I try to think of like, what are the tools that people actually use in real life? And build training around those types of topics, like GitHub Actions, for example. There is no GitHub Actions certification that I know of, but I still build training on GitHub Actions because that's a tool that people use in real life. It's very powerful.
I mean, I think that, and I know that we've been talking very high level today and mostly through theory, but something that we talked about offline was like how PowerShell can help with a lot of this content. And now learning a bit more about it, would it mainly only help with things in Kubernetes, or could it help with things in Docker as well?
Well, talk about opening up a can of worms. I could talk about PowerShell for months. Like I mentioned, I mean, I've been doing PowerShell since 2006 when it came out. And so PowerShell is a cross-platform. A lot of people still don't realize this, but in 2016, so now 6 years ago, Microsoft open sourced PowerShell and made it a cross-platform automation language. So all the same types of things that you would do with Python or Ruby or Java programming languages, pretty much you can do with PowerShell. So it's an automation language that allows you to plug into lots of different platforms. You can use it to call REST APIs, to do cloud provisioning. You can use PowerShell like with bash scripts where you just call out to different executables to run different CLI commands in succession if you want to. PowerShell does support multi-threading too. So if you want to spin up, multiple parallel instances of work that need to be done, you can use PowerShell to accomplish that as well. But it's really just a general purpose programming language that you can use to write scripts. And you can also use PowerShell interactively to just run like one-off commands, like delete this file or, create this file or, whatever you need to do. So it works great for both of those. And you may have noticed I actually use PowerShell here on my local machine as my primary shell. Sorry, my machine's being kind of slow here. But yeah, I just use PowerShell locally here to run commands like get child item to list files on my file system. Or if I go to my Git directory here, take a look at some of the different folders I've created. So I can use this to run various commands. I could run DigitalOcean commands. I could run Kubernetes commands with kube control. So PowerShell works great for that interactive use, but it also works great to do like actual scripting, programming type of tasks too.
I'm letting it set in because I think at this point I'm like, this is my brain hurts. In the fact because it is a lot to go through, but also working on putting it into real life action, and I think that's something that I'm struggling with, but I mean, I do that on everything of like when would I actually use this and in my own processes, but I at least the way when you said PowerShell, the first thing I was thinking was in Python being able to program lights. And I'm like, "Oh, so can you program lights with PowerShell?" That's where my mind went. But I think just also this gave me a lot of thoughts around specific questions I would have here. Like I need a noodle on it to like figure out what the questions fully are, but um this high level overview was really helpful to get an idea, then dig into each of them very separately. So I greatly appreciate that. And is there anything that you think we needed to cover today that we haven't?
Not really. I mean, it's just you got to spend time kind of hands-on with the technology. I always encourage people, get hands-on time with it because the more hands-on time you spend with the technology, the more it's going to make sense, the more it's going to kind of jostle your mind and think about all the possibilities of things you could build. So like the other day you learned about TypeScript. It's like, okay, well, I can use TypeScript to build web applications. Okay.
Hmm.
Um, what kind of application would I want to build? Do I want to build Jen's to-do tracker so I can track all my work that I need to do? Do I want to build uh, a dealership's car inventory tracker so that I can
Yeah.
help a car dealership, track inventory and sell cars? Or, I mean, just think of different use cases for what you want to do and then go out and try to build it.
Hmm.
And as you run into challenges, that's going to prompt you for solving very specific problems. It's like, how do I use
Hmm.
TypeScript to connect to a database? Okay, let's go research that. Okay, how do I use TypeScript to build a front end to a web application or build an API backend? Okay, I'm going to go research that topic. So the more purpose driven that you can be about doing your research and the more experimentation that you do, the better your development journey is going to be and the less abstract things are going to feel.
Yeah.
Because, yeah.
And I appreciate that because I feel like one thing that I've enjoyed about the show is being able to learn about it abstractly to at least kind of understand where I would for your example, like creating type using TypeScript to create a to-do list, like learning about it abstractly will then kind of give me ideas of where to go with it, instead of just not knowing what it did altogether. And to the beautiful humans watching today, and I saw that Ramon also had to go. So bye, Ramon. You didn't see that, but bye, Ramon. Anyone else have any questions before we end our stream today? Rivet, I know if you're still here, you had good questions earlier. So please let us know if you have any questions or hit us both up on the Twitters. And that's our like names there. Ha. Give you guys just a minute. And yeah, it's definitely a lot, but it's like a good amount of a lot. I think I would like it's hard to explain. Ooh,
I get excited
homie,
about all sorts of technology. So, I mean, I get it.
homie said if he used Next.js and Docker, that would you lose some of the Next.js features as opposed to deploying it on Vercel.
Next.js is a really powerful framework, and I really like Next.js. I'm not an expert with it by any stretch of the imagination. But I'm not familiar enough with the Vercel platform to know if they have special integrations with Next.js that you would lose if you spun it up on Docker or just installed it directly on a Linux VM without using containers. I do know that using Next.js as a web framework and API framework to build applications is extremely powerful, regardless of where you run it. But I don't know enough about the Vercel platform specifically to say if you would lose functionality.
That's a curious question, homie, and I appreciate it because I know Vercel created Next.js, right? So I'm curious too if it, without using Vercel, if it would cause issues. We should try
I
to
think
get
the way
someone
that I
from.
would approach,
Oh,
oh, go
go
ahead.
ahead.
I was just going to say the way that I would approach that question is think about what functionality do you need. So like start by developing Next.js locally, right? That's typically where you start with building applications. So start building your application locally. And then if there's a feature that you think you're missing, then go research that and see if it's specific to Vercel. But personally, anytime that I find a platform that's going to add some special feature that's not available in other platforms, I tend to shy away from that because I don't like to get locked into a platform. Like I want to use Next.js to build an app, but I don't want to be locked into just deploying it on Vercel. I want to deploy it on DigitalOcean or Linode or AWS or Azure or something like that. I want to have that flexibility and choice. So anytime that you find something that kind of locks you into a specific direction, that's usually a red flag to me. And I probably would not personally want to take a dependency on whatever that feature is.
Homie, I feel like we need to tweet them and ask them. I'll do that.
Good idea.
We can do that, after this. But yes, needs-based decision making. Thank you. Yes, thank you, homie. Great question and awesome. It looks like we walked away with a lot of to-dos lists, at least for myself, of breaking down a lot of what I was learning to ask the questions. Because today I was just more of like observing it because I was like, I kind of get it, don't get it. And that's one of the things I think is awesome with the show and these videos is I at least know what to go look for instead of just not knowing what I don't know.
Mm-hmm.
So
Once you use Docker, I'm telling you, you're going to use it like every day. Like I use Docker every day. I also use
that's
Kubernetes every day, mainly because I'm building training on it. But I do like have a cluster running on a Linux machine at home too, and it's just like I'm always like, okay, I need to use Docker to run this task or whatever. In fact, to give you a practical application of something that I actually use at home, like in production at home, is I just have a little. Do you know what a Raspberry Pi is? It's like I don't have one handy right now, but they're just these little like micro single board computers, and I've got a bunch of them because they're dirt cheap to buy, but you can run different applications like InfluxDB on them. And so I use Docker to run this InfluxDB web application. And if you want, I can actually show you what it looks like. But it's really cool. It basically just allows you to store metrics and graph metrics. Uh-oh.
Oh, maybe.
Is it going to load?
Here, I'll go back to us and then. Oh,
It's
yep.
loading.
There we go. Cool.
Okay, there we go. So this is InfluxDB. Again, basically a single command to launch it, just like we had with Neo4j or any other container-based application. But what you can do is you can create these buckets where you can store metrics inside of. And so I've got this dashboard right over here that I've created that has, like weather data. It's got performance data. So it's like pinging trevorsullivan.net to see how long it takes to load. So I can see, how long it takes to perform DNS queries or how long it takes to access a website or what ping times I have to different devices on my network. And so this is just kind of a way to like gather data and then graph that data and put it into a meaningful format that you can consume personally. And InfluxDB is open source. It's free. You can run it yourself. And then there's this agent called Telegraph that I also run on the same machine as InfluxDB itself. And the Telegraph agent is what's actually gathering the metrics and then sending them to InfluxDB here. And then InfluxDB is what has this web interface that allows me to actually graph the metrics and kind of make sense of things. So I can add, cells here. I can run queries against different bits of data. If I want SNMP data from network devices, I can grab that and build a graph around it, and then add that to my dashboard here. Here it is. So it's just really cool. It allows you to kind of just graph data.
That's fun.
Yeah, and it's colorful and it just looks really nice, and it's just it's easy to use. Like I
Yeah.
love software that's easy to use,
Hmm.
and InfluxDB is easy to use.
I dig it. I dig it. And Homie Coder says, sick dashboard.
Thank you. You can build your own very easily with Docker and InfluxDB and Telegraph.
So that was Docker, Influx, DB, and what was the other one?
Telegraph, T-L-E-G-R-A-F. So
At
in the
least.
company called Influx Data that makes InfluxDB, they also make that Telegraph agent, which is also open source software. And it's got all these different plugins. And I've actually got some training at CBT Nuggets that talks about like how to configure Telegraph to monitor network devices and basically all the stuff that we're kind of looking at here, and understand how to gather data and then send it to a database like InfluxDB. But it also supports a lot of different output plugins. So InfluxDB is just one of the targets that's supported by Telegraph. But if you wanted to use a different database engine besides InfluxDB, you could use, there's a whole bunch of different database engines out there that you can store data in besides InfluxDB. There's like TIDB, there's Timescale DB. Yeah, there's a whole bunch of different database engines out there that store metrics.
Interesting. Interesting. So, again, lots of homework to look into. I'm enjoying it. And thank you again for hanging out with us today, Trevor. I know we all
Thanks.
appreciate it. And y'all, if you have questions, of course, hit us up on YouTube or go hit Trevor up on um, Twitter. And Rivet says, oh, yay! This was a great one. Rivet's big burning question that they've been carrying around since they first heard of Docker got answered. So, yay!
Good.
Awesome.
Awesome.
And for everybody, make sure that you follow us on Twitch. Have more guests like Trevor and possibly Trevor again. If we can convince him, we'll see. And thank you, everyone. Bye.
Thank you.